Welcome to SKM Academy. Today we are going to see Physics 12th Chapter 1 Example 1.3. So, Coulomb's law of electrostatic force between two point charges and Newton's law of gravitation force between two stationary point masses both have inverse square dependence on the distance between the charges and masses respectively. So we need to compare the strength of these forces by determining the ratio of their magnitudes for an electron and the proton, and also for the two protons, and then estimate the acceleration of electron and proton due to electrical force of their mutual attraction when they are 1 Armstrong apart. So they have given the values for the mass of the proton as well as the mass of the electron. So we know that the gravitation force formula is F of g, which is equal to universal gravitation constant G m1 m2 by r square. And the electrostatic force, which is the Coulomb's law of force of attraction, which is F of E is equal to K Q1 Q2 by R square. So the universal gravitation constant G value will be G is equal to 6.67 into 10 to the power of minus 11 Newton meter square per kg square, and the magnitude of charge on electron or proton, which is 1.6 into 10 to the power of minus 19 Coulomb, and the value of K is 9 into 10 to the power of 9 Newton meter square per Coulomb square. So in A part they have asked to compare the strength of these forces by determining the ratio of their magnitudes for the electron and the proton. So force due to the electron and proton, which is equal to magnitude of electrostatic force by gravitational force. That is equal to K Q1 Q2 by R square into R square by G mass of proton and mass of the electron. So the R square and R square value will get cancelled, and substitute the values for the remaining quantities. So for K, that is 9 into 10 to the power of 9, and the charges were 1.6 into 10 to the power of minus 19 into 1.6 into 10 to the power of minus 19 by, for the gravitation constant, there is 6.67 into 10 to the power of minus 11 into mass of proton is 1.67 into 10 to the power of minus 27, and the mass of the electron is 9.1 into 10 to the power of minus 31. So if you substitute these values, we will get around the value is 0.23 into 10 to the power of 40. Like that, for the second case, the force between two protons, for that we have to take the same procedure as like that above. So electrostatic force by gravitation force, which is equal to K Q1 Q2 by R square into R square by G into mass of proton and again the mass of the proton. So the value will be 9 into 10 to the power of 9 into 1.6 into 10 to the power of minus 19 into 1.6 into 10 to the power of minus 19 by 6.67 into 10 to the power of minus 11 into 1.67 into 10 to the power of minus 27 into 1.67 into 10 to the power of minus 27. So after substituting these quantities, we will get the final value as 1.34 into 10 to the power of 36. And in second case, they are asking to estimate the acceleration of electron and proton due to the electric forces of their mutual attraction when they are 1 angstrom apart. So for acceleration, A is equal to electrostatic force by mass of the electron, which is equal to K Q1 Q2 by R square into mass of the electron, which is equal to the K value of K is 9 into 10 to the power of 9 into 1.6 into 10 to the power of minus 19 into 1.6 into 10 to the power of minus 19 by 10 to the power of minus 10 square into the mass of the electron is 9.1 into 10 to the power of minus 31. So after we calculating these values, we will get the final value as 2.56 into 10 to the power of 22 meter per second square. So it's like that we need to find out for the proton. So acceleration is equal to electrostatic force by mass of the proton, which is equal to K Q1 Q2 by R square into mass of the proton, which is equal to 9 into 10 to the power of 9 into 1.6 into 10 to the power of minus 19 into 1.6 into 10 to the power of minus 19 by 10 to the power of minus 10 square into the mass of the proton is 1.67 into 10 to the power of minus 27. So after calculating this, we will get the final answer as 14.4 into 10 to the power of 18 meter per second square. Thank you.